Good morning, everyone. Thank you very much for attending this webinar. Make better decisions and deliver quality fabrication projects with StruBIM Steel. I'm Cristina Gomez, the country manager for Cype Engineer, and this is David de Dios, our special technician for today's webinar. Today, we are going to present the steel solution that we have, passing through, first of all, the software called Portal Frame Generator for geometric generation of rigid portal frames and simple and multiple trusses. After that, we are going to see the software called Cype 3D. That is for three-dimensional bar structure projects with steel, aluminum, and timber sections, including foundations and bracing systems against lateral loads, and so on. Following up, we are going to see the next software that is Cype Connect. That's a software that we have especially for design, analysis by finite elements, and verification of connections for steel and wooden structures. And finally, we are going to see one of the last software that we have, that is the StruBIM Steel. That's for creation and maintenance of BIM model for structural steel detailing. Right, David?
Correct. And if you'd like to know more about any of the software that we're showing you today, you can always access the application website, where you will have detailed information as well as learning resources for all the tools that we're going to show you today. You will be able also to download and install all of these tools in your computer. And without further ado, I would like to show you around a little bit of the workflow that we propose for steel detailing, as well as for analysis of steel structures. So without further ado, let us jump straight into it. We would start, of course, with the portal frame generator, and I'm going to create now a new project before we continue. Let me first turn off my camera so the connection goes smoother on both sides.
Okay, I do the same.
Okay, so now let's continue and let's create a new portal frame where we're going to insert a new tool page frame. We're going to insert a new frame, as I mentioned, and you can see that we can work with either mono page or dual page frames. Depending on the kind of frame that we've selected, we will be able to work with a predefined library of roofs, like the ones that you can see in here. And of course, we will be able to customize the properties for the description of this geometry, like what I'm going to do right now. So you can see that we can set it up clearly to our liking. But for now, I think we can continue with something like this. Here we're almost there. And now you can see that we have the geometry of our portal frame ready. Basically, we're going to use the portal frame generator as a companion tool to Cype 3D, so that way we will be able to add all of the loads that are required for our structural analysis, things like wind loads, dead loads, light loads, snow loads, and so on, as well as using that to size all the purlins that we're going to have, both on the sides as well as on the roof of our portal frame. So to get into that, let's set up the properties of our frame, like the number of spans as well as the distance between the frames, as you can see here. And,
okay, David. Sorry,
yeah.
I have a question. May I ask you, what will standards are supported by this software? Do you can see that?
Well, of course, all of our software takes into account several building standards from all around the world. And as I mentioned, we can use that when we want to add wind load codes as well as snow load codes. In fact, if you would like to know more about the kinds of building codes that our software supports by default, you can always go to our website, where you can select the country that you're working in. Like, for example, let's say that we're working in South Africa, and you can see that we can filter the supported codes by categories. In this case, of course, we're going to work with structural analysis. So you can see that for South Africa, we support, for example, all of these building codes. And the same thing applies, of course, if you would like to know more about other countries.
I see. Mm-hmm.
So going back here to the portal frame generator, in this case, I'm going to work with Eurocode. But of course, as you can see, we also support other standards like the American standard, British standard, Brazilian, Indian, and so on. And it's just a matter of setting up a series of uh, parameters that we're going to use for the analysis, like, for example, the location data, reference speed, and so on, terrain category, land orography, service period, and so on. We can even take into account facade openings if necessary, as you can see here in this diagram. So that way we can even analyze the suction pressures depending on the direction of the wind, as you can see here. But in this case, I'm going to work just with the default values for the sake of this demonstration. And same thing applies, of course, with the cladding that I mentioned before. We can have both dead loads as well as live loads that are linked to these elements. And this is what we're going to do right now. We're going to add a roof cladding with external panel weights of, for example, 0.2 kilonewtons by square meter. And if necessary, we can also have live loads for the external panels as well, as you can see in here. Same thing applies for the lateral wall cladding. And once we're done, we can set up things like, for example, the use case for this category. And just by clicking accept, I will have all of these loads applied automatically to my frame. So once we have that, the next step would be, of course, to carry out the analysis of our frame. And to do that, we can go here to the purlins editor, and we're going to add, for example, some purlins on the roof. And as you can see, we can set up a series of parameters for the analysis data, as you can see. And I'm talking about things like, for example, the deflection limit for each span when we're adding these roof purlins, as well as the number of spans that it is going to go across, as well as the type of attachment for things like buckling lengths and so on. Once I have the analysis data ready, I will be able to design the actual purlin. And this can be designed depending on one of these three variables I'm going to work with. So that means that I can set the other two, and the software will be able to size the purlins according to this parameter. Like, for example, we could set the distance between the purlins, separation as 1 meter, and the steel type as, for example, this grade right here. And then by selecting the section type, we'll be able to size our purlins according to this section selection. So maybe I could use something like this. And when I click on design, the software will be able to size this purlin accordingly. It's going to work through an iterative process. And once we're done, let's see that the software will have selected the best fitting solution from this section series. In our case, the best fitting one would be this one right here. As you can see that it meets all the code checks. So let's select that, accept, accept. We can even take a look at the checks if we want. And indeed, everything has gone accordingly. So we can just click accept once more. And now you can see that our structure has the purlins ready. Same thing would apply if we wanted to generate the purlins on the sides as well. And once we're done designing our portal frame, we'll be able to export all of this data to Cype 3D. So that way we can set up the rest of the structure. And I'm talking about things like bracings as well as other kinds of structural elements like beams, columns that may be missing, and so on. This is something that I've already done here previously. And the final result should look something like this. This is Cype 3D, as I mentioned. And inside 3D, we work freely in a 3D space with a nodes and bars approach to modeling. And if I'm working with standard structures, with frame structures like this one, I can just start directly here in the portal frame generator, and I can send all of the details in here so that I can continue adding things like, for example, these bars that you're seeing here, as well as bracing and so on. For example, if we add a bar in here, you can see that we can select a material that we're going to work with for our section, and this includes, of course, rolled steel as well as core foam steel, timber, aluminium, mass concrete, and so on. And of course, the software comes pre-built with a section series for all of these materials, which will be updated accordingly once you select the section series you would like to work with. And of course, we can even go one step ahead and we can even set up the layout data for this beam that we're going to work with. So if we wanted to, for example, have a layout with lateral plates or with web openings, like for example hexagonal, octagonal, or circular ones, or if we wanted to, for example, have haunches as well, that's something that we can take into account as well for the layout.
That's impressive.
And of course, when we're done with the modeling, we will be able to run the analysis, so the software is going to size all of the elements accordingly.
I have a question. Does the software apply performance-based design criteria when sizing the bars?
Well, of course, as you can see, we can either set the section design by default, that is just working with the sections that we've designed here previously, or what we can do is that we can run either a quick section design or an optimum section design, where we will be able to work with an iterative analysis that will have results like these ones.
Okay.
So you can see that I've selected this section series, and the software has selected the best fitting one depending on the features of each bar. And we can even get as far as taking a look at the step-by-step analysis that we've done for each bar, as you can see in here. We can generate reports with all of this data actually, and this is something that I'm going to generate now in real time as we're speaking. You can see that we are citing the building code, the articles, formulae, and steps that are required to get to the final result for the sizing and the final checks. And when we're done, we'll be able to export all of that into PDF, HTML, Word, and so on. So you could have, for example, something like this.
Perfect.
And of course, in Cype 3D, we can not only design our structure at a bar level, but we can also design automatically and size all of the joints that our structure may have. Let me show you here an example. This joint has been generated automatically by the software according to the libraries that we have pre-built into it. And as you can see, we can work with both welded joints as well as bolted joints.
And one question, what kind of joints come pre-built into Cype 3D?
Well, if you'd like to know more about the joints that come pre-built into Cype 3D, you can always go into any of these links that we have in here, which will send you to a complete list of all the welded and bolted joints that software contains by default. So what is going to happen is that Cype 3D is going to detect your nodes and it's going to apply the best fitting solution for all joints that we have in here. And it's going to be able to generate it either as a welded or bolted joint, which is what I'm going to do right now. And we can take a look at step-by-step analysis, just like this before, as well as the detailing, the drawings, which is generated also by the software as well.
And one other question. What happens when Cype 3D does not have our join?
Well, Cype 3D is meant for your standard jobs, like for example, this structure that we're seeing right here. And we could have automatic detailing for the joints that we've seen before, so that we can generate drawings like, for example, these ones. But of course, we've got you covered if you're working with somewhat more specific structures that may require customized joints. Let me show you here an example of the drawings that I was talking about. And you can see that in Cype 3D we can generate foundation layouts like these ones. Very simple arrangement drawings in 3D like these ones, as well as all the detailing for the joints that we've seen before. This is something that has been generated by the software automatically according to the libraries that we've seen before. But of course, you won't be working all the time with these standard joints, and to go further, what you can do is that you can export all of this data to BIMserver.center, and there we can continue, for example, with CyPECAD. You can see here I have a complex structure, and what I did is that I exported all of this data to a project so I can continue with CyPECAD. Let me show you here. And you can see that we've been able to reuse all the analysis data from Cype 3D into CyPECAD. So that way we can design our own custom joints with a step-by-step both modeling as well as analysis. This is something that I've already done here. So let's take a look at this joint, for example. And as you can see, in CyPECAD, we work with a series of operations, and I'm talking about things like, for example, anchors, stiffeners, bolts, welds, openings, plates, trims, and so on, which we will apply so that we can generate our custom joint. We start with an empty canvas, as you can see in here, and for example, we could start by adding a front plate to section T3, like so. And as you can see, the properties of these elements can be customized. I'm talking about things like, for example, thickness, as well as the type of plate, which can be either rectangular or freeform, as well as, for example, in this case, the overhangs that we're going to have in regards to the section that we're going to work with. We can continue, for example, by adding welds, which is something that we can do manually like so, or that we can add automatically to the flanges of my section. We can also customize the kind of connection type we are going to have. We can either have a fillet weld, a butt weld, or a lap weld. And we can even change the throat widthness as well as the initial and final displacements. This is something quite interesting that we can take into account later when we run the analysis, because we will be able to not only check the integrity of our elements as well as the buckling and rotational stiffness for the whole joint. But for now, let's continue, for example, with this standalone welds like so. And for example, we could add a trim to section V2. So that way we could have, for example, a chord radius, a drill or straight trim like these ones, which we'll be able to customize as well, like so. And in this case, I would like to have also a lateral plate here in section V2. But as you can see, they can also be standalone, freeform in the space, or they can be attached, like you can see here, to the webs or to the flanges of our section, as well as perpendicular to any of those elements as well. I'm going to work with an attached plate in this case. And you can see that we can work with either rectangular ones, or if necessary, we can even work with polygonal ones, where we can add all of the nodes for our polygon, or we can just use the polygon generator in here. So you could have, for example, something like this. But in this case, I'm going to work with a rectangular one, like so. And let's weld it here to section V1. Let's add some bolts, which we can either add manually, just like we did before with the nodes of our polygon, or we can add them with the help of the bolt generator. So that way we can have rows and columns of bolts that are going to be added automatically throughout my section, as you can see here, by using the local axis of my plate. We can even customize the type and material of bolt that we're going to use. And it looks like my section is more or less ready. So that means that the next step would be to go into the analysis. But before we get into that, we can create our own connections library if we want. We can export all of this data to the connections library. Let's give it a reference. And that way we will be able to reuse all of these joints in the future if we wanted to, either in this project or in future projects as well. So let's continue here with the analysis. And as we mentioned before, we can have just a basic stress strain analysis, or we can even go as far as having rotational stiffness as well as a buckling analysis. In this case, we've worked with a Cype 3D model, so we already have the loads and load cases. But in case we're working with third-party models, we can just go ahead and customize all of the values for the load cases as well as for the forces in the rotational stiffness analysis. I'm going to run now the analysis.
Sorry, I have a question. How are the elements discretized when you run the analysis?
Well, in SiteConnect, what we do is that we work with a finite element analysis engine, which is OpenSys, developed by the University of California at Berkeley. And what we're doing is that we are taking all of the elements that we've modeled previously, and we are discretizing them into finite element entities. In this case, I'm working, for example, with a 40 millimeter discretization size, but this is something that we can customize as well. And we're going to turn elements like, for example, the sections or the plates into shell elements, as well as, for example, welds, which will be turned into point elements, and bolts, which will be turned into spring elements. Okay, so now that the analysis is done, you can see that we can view the final results either visually, like for example, here in this 3D view, with the help of the maximum demand capacity ratios, where we can see how each element has been optimized for this design. And in this case, you can see that these two bolts that I have in here are overstressed in comparison to this one, which is understressed. So that means that you can use SiteConnect as a way of understanding how your design works and as a way of optimizing your resources. Same thing applies, for example, if you would like to take a look at the von Mises stresses, and you can see here the discretization that we were talking about before for all the elements. And we can even take a look, for example, at the deformed shapes for all the bars in here. And this is basically a more scientific approach, let's just put it like that, to complex joint design and analysis, where we can have a better understanding of the behavior of the joints that we're going to customize. Last but not least, if you've paid attention here on the right side of my screen, we can also take a look at the checks that have been carried out according to the components-based analysis. And we can even generate a full report with all of these elements. We can either have a summary like this one, which is being generated now as we speak, Or we can generate a step-by-step analysis, just like we did before in Cype 3D. And when we're done, we'll be able to export all of this data, if we want, into a PDF, HTML, Word, and so on. You can see that we take into account things like, for example, the bolt hole layout, shear resistance, bearing resistance, axial strength, and so on for all of the elements that we've mentioned. And of course, last but not least, we can also generate the drawings for our custom joint. We normally start with an empty canvas like this one, and then we are able to automatically insert some predefined views that come from the model that we have generated previously.
And what happens to the drawings if I edit the joints?
Well, as I mentioned, all of these drawings are generated off of the model that we've generated before. So that means that if, for example, we were to, let's say, get rid of some elements like this bolt right here, you will see that now in the drawings that I've generated, the views have been updated accordingly. So there's no need to regenerate all of these detailings when we are editing and designing our own joints.
Great.
We can populate this drawing with several elements, like, for example, smart tags that read all of the data directly from the model. So we can have tags like these ones for things like sections, plates, welds, bolts, and so on, as well as, of course, dimensions that we're going to add to all of the elements that we're seeing here. And as we mentioned before, if we were to edit any of the properties of the model, these tags as well as the views will be updated accordingly as well. And when we're done, we'll be able to export all of that into either a PDF, DXF, DWG, and so on. But of course, in this case, we're just working with joints. And if you would like to have full detailing for your building, including, of course, general arrangement drawings, as well as parts and assemblies drawings, we could use StruBIM Steel for that. You can see that I have here a project that I've imported previously from Cype 3D, and I've already generated all the joints as well as all the assemblies and so on.
David, one thing, you say that you export this from Cype software, but can I import the structural models from other softwares?
Indeed, if you go to the BIMserver.center store, you will see that we have tools like, for example, the IFC uploader, which we provide for free as well,
Oh, free.
which you can use to upload any kind of IFC file from any third-party modeler. So that way you can reuse the data that you've generated with other analysis tools so that you can carry out that detailing directly in our software.
Okay. And another question. What if I don't have any structural model?
Well, in that case, we've got you covered. You can just start from scratch, either directly in a 3D space with the use of grids, like the ones that we're seeing here, or we can even import DXF and DWG drawings, like this one, for example, which we can use as a basis to start modeling our structure.
Okay.
So it's completely up to the engineer, as you can see.
Perfect. Thank you.
So just for this demonstration's sake, I'm going to add some elements here from scratch so that we can complement the structure that we have imported with some edits that may be necessary later. Like, for example, I'm going to add here a new section, and as you can see, I can just use the script that I've imported as a basis, or I can just snap to the existing elements as well as to the drawings I've imported before. So I can do something like this.
I have another question. What sections are supported by the software?
Well, as you can see here on the properties window here on the left, we can either work with rolled steel as well as built-up sections with rolled steel plates, cold form steel, tubular sections, and since patch 2024.b, we can even work with PV sections like these ones. So you can see that in this sense, the software is quite flexible. So going back to the example that we're having here, you can see that once we put the material that we're going to work with, we can work with a series of predefined material and section series, like these ones. And of course, if you are missing something, you can always customize those libraries to your liking as well. So we can have our own custom section series for all of the elements that I've mentioned before.
Okay.
And when we are done with that, we will be able to carry out the detailing for all of these elements. In this case, you can see that I've also grouped some entities into assemblies like these ones, which you can see here. And of course, if you know how to use CypeConnect, StruBIM Steel works exactly the same way if you want to design your own joints, which is something that is quite straightforward, as you can see. So that means that if you needed to, you could have CypeConnect integrated into StruBIM Steel as well. So if you know how to model joints, just like we did before in CypeConnect, you can just have them as a modeling tool, or you can use it as both a modeling and analysis tool. So that way you can review how the different changes that you may apply later during the detailing stages reflect on the behavior of your joint. So you can see this is exactly the same interface as what we've seen before here in CypeConnect.
Okay.
And of course, when I'm done modeling all the different joints that I have, as well as grouping all the assemblies, like for example, these ones that we're seeing right here, we'll be able to carry out the composition of all of our drones.
Okay, so this is the numbering of all the elements.
Exactly.
Will it be updated when I add new ones?
Well, in this case, you can see that I've added a new bar in this element, in this structure right here. So what I can do is that I can renumber accordingly all of the bars I have in here with the prefixes for each element, sections, bolts, plates, and so on, as well as taking into account the initial number in case we wanted to add a displacement, not only to the parts, but also to the assemblies as well. So we can keep the original numbers, or we can number everything at the same time, so it all takes concordance with the numbers that we've used previously. Or we can go on by reusing the last used number. So it's completely up to us, as you can see.
Okay.
In this case, I'm going to renumber them from the initial element number, like so. And the software is going to generate all the detailing accordingly. And once this is done, we will be able to have parts drawings like these ones, which have been generated automatically by the software, as you can see. And this interface actually is quite similar to what we've seen before in CypeConnect, but of course with the added benefit that we can have parts drawings like these ones, as well as assembly drawings like this one, for example.
I see.
And of course, we can have detailing for the joints as we did before in CypeConnect. And last but not least, general arrangement drawings.
Okay.
And when we're done, we will be able to export all of this data into several formats, just like we did previously, so that we can export all of these into a PDF, DXF, DWG, and so on.
Okay, and I have a question. I know that in other Cype software like MAP software, you also can generate reports. It's possible in this software as well?
Well, of course, it's not the only kind of deliverable that we can generate in StruBIM Steel. We can generate analog deliverables like PDF, DXF, DWG, and so on. And we can also generate digital ones like the STB and step files for manufacturing, as well as IFC EM11. So that way we can cooperate with third-party software. And of course, in regards to the reports that we can also generate a full report with the checks and quantities that we've carried out for all of the elements in our structure, like so.
Okay, great.
And when we're done, we can export all of these into either a PDF, HTML, Word, and so on. And same thing applies with your structure. You can send back all of this data to BIMserver.center, so that way you can reap the benefits of working in an OpenBIM environment. You could create a new project where you can store all of this data, which is what I've done in here. And I can send all of this data to third parties. I could invite any users to collaborate and reuse all of this data. I could have a federated model where I can have several contributions making up the full description of our structure. And I can even access the 3D viewer as well as augmented reality and virtual reality tools that we have. So that way anyone will be able to review the project in real time, as you can see, by interacting with the different elements of my structure and so on.
Okay, so thank you very much for your presentation, David. As far as I can see, everything has the same workflow at all times. Once we have created the project in BIMserver.center or created directly in the portal frame generated, we link the software that we are going to use to the project, and once working on, we upload it back to the platform, generating a simple and very effective workflow. So, as this is the end of this webinar, I want to thank all the participants or the people that has registered. Then I want to say that we have an exclusive offer on the software that we have presented today. And as you can see, we have there my email, cristina.gomez@cype.com, that you can send any question about the workflow, about the webinar, or also if you have more specific technical questions, you have also the support@cype.com, and you can send it there. And again, thank you very much for attending the webinar, and have a great day. Thank you, David.
Thank you all. See you soon.